All right, thank you. So today we'll be talking about building the ideal stack for real-time analytics. And this talk is scheduled for 15 minutes long. So this talk could go for a while. So if you have more questions after this, feel free to grab me or feel free to stop by our booth. MemSQL, we have a booth down at the Expo Hall. So we can chat there as well. Before I launch into the discussion, it's first important to note where we are coming from this as a company. So what is MemSQL? Who are we? Why do we care about this space? So just really quick about MemSQL. At MemSQL, we build a database platform. So we build a database. We were recently ranked by Gartner as the #1 operational data warehouse. If you're interested in the paper, you can go to our website on memsql.com, or you can also get it from Gartner. MemSQL is a database that is real-time, and by real-time I mean very, very fast, and we can talk more about that in a bit. It is scalable, so it can scale to whatever nodes you have in your system, and it uses the proven SQL syntax. So we are a SQL database at its core. The mission of MemSQL is to make every company a real-time enterprise. And what does that mean? That really means enable every company to build a real-time data pipeline and have real-time analytics on that pipeline. So we very much as a company care about accelerating the way you get analytics from your data as it comes in. So more on that. Let's talk a little bit about real-time analytics. For the purposes of this talk, this is how we are going to define it. It really means that you want to gain insight and insights that provide meaning to your business from data as it comes in. So you don't want to do a batch job and do the analytics later, the analysis later. You want to do the analytics as your data is piping into the system. Whenever people mention real-time, usually they're talking about, or in my experience, whenever you first mention real-time, they think about weblogs, they think about IoT, they think about mobile. But really, the way we see real-time is, it's a huge opportunity. You can take the existing processes that you have right now that are running in batch and make that into real-time systems. With the technologies that exist today, not just in MemSQL, but with other technologies as well, you can build real-time data pipelines. We also polled our customers and prospects and the other people we've interacted with on what are the different real-time analytics opportunities that they're pursuing in their company. And we found everything from building a dashboard that's real-time, to improving the customer experience, to increasing efficiency, and creating new revenue opportunities. So there's a lot of reasons why you'd want to do real-time. So now let's jump in. What is the ideal real-time stack from our experience, from what we see in our company? Well, we really see four big things, right? And we'll talk about them one by one. Let's start from the right, the real-time visualization. So at the core of every real-time data pipeline and to create real-time analytics, to sell the idea of real-time analytics to the business, you need a dashboard. All the customers we've worked with, there's some sort of visualization. It's either homegrown or it's one of the third-party platforms, Tableau, Zoom Data, Looker, MicroStrategy, Click, you name it. Now, the commonality of all these business intelligence tools that have dashboards like this is that they're only the interface. They usually don't provide the backing data store. You need a place that stores your data that's really, really fast to be able to come up with the real-time insight. And so to be able to make your real-time visualization or your visualization real-time, you need a real-time backing store. And moreover, these sorts of visualizations only attach to backing stores that speak a certain language, meaning they have to be compliant with certain syntax. And the most prevalent of which out there is SQL, is SQL. So more on the data persistence piece. You can see there in the upper, you can see there in the upper right the four icons. The one on the very right is real-time visualization. Next to it is this data persistence piece. What are the characteristics of a data persistence piece for real-time analytics? Well, in our mind, it's these four. First, it needs to leverage in-memory and solid state. If you have a database that doesn't use in-memory and solid state these days, it's probably not fast enough for your purposes. Second, the fastest databases are distributed because you want to be storing your data in many nodes and processing all of that in parallel. You want massively parallel processing to be able to retrieve your data. Third, you need a data persistence store that can connect to various sources. It's not important only to support like the pure SQL coming in, but perhaps data stores need to be able to go and grab data from other sources. And fourth, you need to deploy on the cloud and on premises. More and more workloads that we see are moving to the cloud, and cloud is an increasingly strong player in this space. So in other words, what MemSQL is actually all these four. We are a scalable SQL database. So when you think about MemSQL, think about it as you would think about MySQL or Postgres or Oracle, like the SQL databases that are compliant with the ANSI SQL standard at scale. So we have the scale. Next, so notice it's a bit, the third piece of the pipeline is the message queue. So you have, just to recap, you have the real-time visualization piece. Under that, you have the backing store, the database. Then you also need a message queue. A lot of the time, when we see real-time analytics workloads, the data is coming in so many different formats, and it's typically not structured. To be able to handle that, usually like data from sensors should come into something like a message queue. And the most popular one we see, based on our experience, is Kafka. But there are other stores like ActiveMQ, RabbitMQ, and other JMS queues that do the same thing. So you need a message queue. And finally, in between the message queue and the persistent database is usually some amount of transformation. And that transformation can be done with Spark, can also be done by other technologies, but since we are at Spark Summit, we will talk about how people use Spark. With a transformation tier, you can do things like enriching the streams as they come in. You can enrich it with metadata. You can do real-time machine learning, meaning the data comes in, you do machine learning not just on that data coming in, but you also pull data from the backing data store and perform the analysis in Spark. You can also do more complex transformations and connect to other various systems with Apache Spark. But I don't need to explain it to this crowd. So just to recap, what do we have? The ideal real-time analytics stack is these four things. From left to right, first, you need a message queue that can handle various data formats and structures of data. Ideally also, one thing to mention is the message queue should also be distributed if possible. Second, once you have the data there, it should go to a transformation tier. And in that transformation tier, you can perform more complex processing. Third, it should go into a data persistence tier that is scalable and that leverages all the latest technologies. And also, the data persistence tier should be able to talk to, the fourth piece, the real-time visualization piece, which typically requires that the data persistence piece talks SQL or another syntax that is widely used in the market. Okay, we're going to jump into specific use cases. So in our world, we've actually seen this, or the previous slide, we've seen this in practice many times already. The first customer that I'll talk about here is Pinterest. So Pinterest uses a pipeline that looks similar to what I described to perform real-time analytics for ad targeting. So here's specifically what they do. All the pins and repins that you do from your mobile devices or from the desktop are pumped into Kafka. And from Kafka, they are then enriched in Spark. They actually add location information and other information to it, and then stored into MemSQL. From MemSQL, they can then perform queries, ad hoc queries, to test. Usually they do A/B tests for their ad targeting purposes. And the big sort of innovation or the big technical benefit here is that they are doing 1 gigabyte a second of ingest. So that is around 72 terabytes of ingest, and they're all doing that they're getting real-time analytics from all that data streaming into the system. The use case that I'd like to highlight is an energy company. Unfortunately, we can't say their name here, but we can chat more about their use case now and also after. This energy company does a real-time analytics pipeline to determine the state of their drills. So this is an oil and gas company drilling for oil, and they need to know if they drill a certain direction and the drill hits bedrock, that is very bad. Each drill bit costs them millions of dollars. So what they need to do is in real time determine whether or not they're going the right way. So how they do it is this. They have real-time inputs coming from their sensors. They pump that all into Kafka. So all the sensor information from all their drill bits. Once there, they send the data through Spark and run a predictive analytics model on it. The model is actually, they develop it in SAS, and they use Spark to execute the machine model, or to do the model scoring. Once there, they can then put the results in MemSQL to be able to decide whether or not they should do certain proactive actions with their drill bits. So this is another example of a real-time data pipeline that provides real-time analytics. And finally, just to bring it all home, I have a quick demo here set up. In this demo, let's just go to it right now. If internet works, we should be good. All right, internet works. So this demo here shows you data from 2 million sensors that are on wind turbines located all over the world. This demo is a simulation. The locations of the wind turbines are real. This is a real data set, but the activity of those sensors is what's simulated here. You'll notice here that I can move around the globe and see where all my wind farms and wind turbines are. And I'm specifically going into Europe because I know that there are lots of wind farms and wind turbines in Eastern Europe. The pipeline here is as follows. All the information from all these, this is very similar to the energy company use case that I was just mentioning. All the data from all these wind turbines, each of them has sensors. And that data goes all into Kafka. From Kafka, it then goes into Spark, and there we perform a simple regression analysis model to determine where or how we expect the wind turbine to behave. So the ones that we see as yellow or green or red essentially is our prediction of how those turbines will behave over time. So the ones that are red, we expect that you should probably replace it soon. The ones that are yellow are getting there. And you'll notice that the red ones eventually turn to green because the expectation is that it's a model where things are slowly decaying over time or degrading over time, and then they get repaired. And they're degrading, and then they get repaired. So you can see here a visualization of all that in real time. Behind the scenes, everything's running on this Kafka to Spark to MemSQL pipeline. This is a view of MemSQL Ops, which is our graphical dashboard for looking at MemSQL clusters. As I described earlier, MemSQL is a distributed database, which means it exists, or you install the same software across many systems, or across many machines. So here you see it has 16 machines, and all those machines are humming. If you see those green, it means that the CPU is going with MemSQL. So why is it going? It's because in real time, the data is coming from Kafka to Spark to MemSQL and rendered here in this dashboard. So you can notice that sort of every second, it's refreshing, showing users new insights based on real-time data that's coming into the pipeline. Last slide here is just a quick plug. For the last 30 seconds, if you're interested in learning more about MemSQL, come visit us at the booth. We're in booth 308. If you're interested in building real-time data pipelines or in machine learning, we also have 2 books that we worked on in cooperation with O'Reilly that you can come grab from us. And moreover, if you're more interested in MemSQL, we also have a talk tomorrow delivered by our CTO. And you can check the schedule in your booklets. So with that, thank you very much for your time and have a great day.